Hi, today I'm going to talk about living hinges, which is a way to make an otherwise rigid material like wood or acrylic flexible by cutting a pattern in it with a laser cutter. I'm going to talk about a test I ran with a variety of different samples and what I learned about how to make these hinges both flexible and durable. And I'm going to talk about the value of having knowledge of living hinges when you design things like this bracelet that I designed with living hinges. So I'm going to talk about all that in this episode. Hi, welcome to Gray Lightning, my video blog about making things and playing games. And in my last episode, I talked about a brainstorming session I did with Claude, which is an AI chatbot that I had asked to help me to come up with new ideas for new projects for my channel. And Claude came up with a very wide ranging list of possible ideas. But the thing that really caught my eye was living hinges, because I had heard about them and I've seen pictures of them, but I had never actually made any. So I thought that that would be a great skill to add to my design toolkit. So where I started then, after I decided that living hinges was what I was going to investigate, is I asked Claude, well, first of all, where does this idea even come from and the name come from? And he said that it was developed in the plastics industry and injection molded plastics. And it was used to figure out how to integrate a long-lasting, durable, but simple hinge into plastic items, like connecting the cap of a shampoo bottle to the bottle itself. That little flexible piece of plastic that would hold the cap on is a living hinge. And what it needs to be able to do is not only bend, but it has to be able to bend repeatedly without breaking. So that's what the whole design purpose of a living hinge was. Now, of course, we're applying it in a very different arena with laser cutting wood and acrylic. The next thing then I asked Claude to do is to help me put together a test suite that would help me go up the learning curve about what the main factors were in a living hinge and how varying them would impact those design goals of flexibility and durability. To start with, then, you really need to understand what are the basic elements that you're varying in the design of a living hinge. So this is actually the first one I designed. I was just honestly amazed after I cut it because it is remarkably flexible. So this was my first attempt. This is a pattern that's called the standard kerf pattern. It's just basically straight lines and with spaces in between, and then from one row to the next, they're 50% moved relative to the other, so it's kind of like a brick pattern. So you're trying to get a combination of obviously a whole piece of whole material, but you need that flexibility. So the main things that you're varying in this design are cut length, bridge width, and row spacing. So the cuts are pretty self-explanatory. They're these cuts in the wood. It's the number of them and the spacing between them. And the spacing between them is the bridge. So you have the length of the cut. You have a solid space between cuts called the bridge. And how wide that is has an impact on the hinge. And then the cuts and the bridges together make up a row. And then you have row spacing across the body of the hinge. So those are the main variables in the design itself. There's the pattern, so standard kerf pattern here. But the other two patterns I test in my little test suite here is a wave pattern, which is actually very similar to the standard kerf pattern, but with a wavy line instead of a straight line. And I tried this one, but it was really kind of a waste of my time. It's called a cross pattern. In theory, this has flexibility in 2 dimensions, but it does it at the expense of flexibility in the primary direction. And since what I'm really going to focus on initially is flexibility and durability in a single bending direction, I did this, but it didn't teach me much, except it doesn't bend very well. So length of cut, width of bridge, row spacing, pattern, and then the other dimension is how this hinge is oriented relative to the grain of the wood you're cutting it out of. And I'm going to go into this more in a bit, but this actually ends up being the single most important element, and also had some surprises for me. So we're going to talk about that. The other thing is it's really amazing once you add a knowledge of this to your design skills, what you can do with it. And then we're going to talk a little bit about this bracelet, but I'm going to do a separate video on it because it's really a very interesting project in and of itself, and it incorporates UV resin. It's kind of cool. So I'll be talking more about that. So let's talk about sample 1, standard kerf, versus these other two patterns, the wave pattern and this cross pattern. As I said, this is not nearly as flexible in the main dimension that we're trying to measure on this hinge. The wave is very flexible, but it actually broke, partially broke in just standard handling of it. And when you look closely at the design, you can see that the cuts get very close together where the wave lines overlap. And so that makes this a more fragile, inherently more fragile design. If you want to use it, you can, but you're going to have to increase the row spacing to make more material there between where these cuts cross over one another. So that's the impact of pattern. And of course, there are many other patterns, and I have other patterns that I've done since then. And some of them look very interesting, but I have to tell you in the end, if what you care about is just how flexible this is in this one direction, it's hard to beat the standard kerf pattern. And that's why that's what I used in my bracelet here that we'll talk about at the end of the video. So now, what's the next thing that we vary? This sample 1 has the closest row spacing. I have 2 other samples that are identical to this, but the row spacing gets greater between them. The net effect is it makes it less flexible, as you'd expect. The farther apart these rows are, the less flexible it is. One would also think it's more durable, but in my samples, all 3 of them were able to flex without breaking quite successfully. So that was it. Now the other 2, the length of the cut and the width of the bridge, we treated them like they were separate elements, but in reality, they are 2 interrelated. Obviously, if you make the cuts shorter, then either you have to put in more cuts and therefore more bridges, or the bridges get wider. One way or another, those 2 things, the length of the cut and the width of the bridge, are highly interrelated with one another. And I would summarize the results this way. They work together, and I would think of it as a ratio of cut to solid board on a given row. As long as that ratio stays kind of 95% to cut to 5% solid, you're going to get a successful living hinge. You can vary that maybe to 90-10, but I wouldn't go below 90-10, because when you do, you start getting into these other kind of patterns that don't really have much flexibility at all. So the final thing, and then to me the most interesting, was the impact of aligning the hinge with the grain. And you do want to have the grain of the wood parallel to the length of the hinge for maximum flexibility. So if I just look at sample 1 and sample 8, this is the one that was not aligned with the grain, and this is the one that was. All you have to do is do this. And I mean, there are bend tests you can do and see when they break and that sort of thing, and I did some of that. But I wanted these samples to survive for this video, so I didn't force them that far. But it really is very obvious when you do this. You can tell which is stiffer and which is more flexible. What was interesting, though, is when we set up the test, we thought this was the one that was aligned with the grain, and this is the one that wasn't. And that's when it comes down to learning about plywood. Plywood, by definition, is multiple plies. And you can only visually inspect the veneer that's on the front and the back. And when I looked at the veneer of these boards were rectangles. They were 12 inches by 18 inches. The veneer was aligned with the length of the board, and that's why we originally laid things out like this. But it turned out, once we cut it and found out that the one that was running vertically was more flexible, that we know by default, basically, that the internal layers of the plywood, at least my plywood, were opposite of what you could see in the veneer, and the veneer was the thinnest part of the wood, and the wood in the middle was the bigger part of the mass of the board, and therefore it's more important to align with that. What's the takeaway on that? I don't think you can trust any plywood. I think you need to test it. So run identical samples and put one vertical and put one horizontal and see which way it is. And then once you learn that for that wood, hopefully that supplier is consistent and you can just lay it out without testing every time. So that's my takeaway of testing. Pattern's very important, but if what you care about is flexibility in one direction, it's hard to beat the standard kerf unless you're just looking for a different look, in which case you could make something like the wave work, but you're going to need to play around with the row spacing to make it durable enough. When it comes to the length of the cut and the width of the bridges in a given row, that is more about the combination of the two. It's more about net to gross or percentage cut to percentage solid. And the higher the percentage of cut, the more flexible it's going to be, but the lower the durability is going to be. Though frankly, this does not just seem to be as nearly a big a durability issue as row spacing is. Row spacing then, the further apart the rows, the more durable it is, but the less flexible it is, and that has a big impact on flexibility. And the final takeaway is always align it with properly relative to the grain in the board you're working on. Now that we know kind of the anatomy of a living hinge, and we know that one of the most important designs that you can learn to make is the standard kerf pattern, I'm going to show you just how easy it is to design one of these in your drawing program. I'm going to do it in Illustrator, but you can easily replicate this in whatever drawing program you use. These are the kinds of instructions I got from Claude about how to do the pattern, and it's a combination of information in inches and some in millimeters. The way I dealt with this is based on how I set up my document. The bracelet is laid out like this, and you can see the space that I have here for the living hinge. It's 1.5 inches by 5/8 of an inch wide. So I went to Preferences, Edit Preferences, and for the grid, I said make it 1 inch, grid line every 1 inch, and 8 subdivisions, so each box is 1/8 of an inch. Then I went to the general settings, and the keyboard increment here, it says inches right now, but I got that by putting in 0.2 millimeters, and it changes it to the equivalent in inches. And that means every time I use the arrow keys to move around, it's going to be moving 0.2 millimeters. In my example here, I have a green reference box, which is the size of the hinge I want to make, and I'm going to open this up and put the lock on that layer so that I don't select it accidentally while I'm selecting cuts. I already have my first row, and it has 2 cuts with a bridge in the middle, and that equals a 6% solid to 94% cut. I'm going to select my 2 cuts and group them, and then I'm going to cut and paste them. I want to make this second row offset from the first one in this brick pattern. That means that this bridge here needs to be in the middle of the first cut. And then I'm going to need to ungroup it and grab one of those cuts, copy and paste that, and put it down at the bottom for the third cut. Now I'm going to have 2 bridges, and I want to adjust the size of those to control that percentage net to gross. And I'm going to actually make those a size that gives the total row a 9% solid and a 91% cut. I control the bridge size by moving a cut segment up till it touches the one above it, and then using the arrow keys to move it down. Once I'm satisfied, I group the 3 cut segments together as a row, and now I'm going to work on row spacing. I'm going to do that by moving the second row on top of the first row, and then using the arrow key to move it to the right. So now I know every time I push the little arrow key, it's going to be 0.2 millimeters that it's moving to the right, and I count up to 6 to get 1.2 millimeters. The last thing we need to do to perfect these 2 rows is to adjust the top and the bottom, because we want them to go across the edge of the piece, because it's very important that every row cut through the edge. And the only way to guarantee that is by extending the cut line beyond the edge. So I just take the direct selection tool and I grab the little anchors and I move them up so that they're just cutting through. And I have to do that for both rows. Now that I have these 2 rows perfected, at least perfect enough, I select them, and I'm going to efficiently cut and paste them. In Illustrator, a Shift Control V copies the piece directly on top of the source. So then I can use my arrow keys to move over that 1.2 millimeter. And it's just a matter then of grabbing now the bigger group and doing the same thing. And eventually I get to the edge of the hinge, and I go over the edge a bit. I'm going to get one more row here. I'll grab these first 2 rows and copy and paste them, put them all the way over. It's going to run a little bit over the edge. I'll get rid of the very last one, then grab the whole piece that's left and center it inside of the green box. And now my hinge is done. Let's talk a little bit then about this project here, my bracelet. And I am going to do a separate video on this because I think it's an amazing little project with a lot of potential. I keep thinking about having parties, you know, if you have a bunch of kids somewhere between the ages of 10 and 20 that you want to have a nice little craft thing for them to do. It's going to be hard to beat a project like this. So, but this design here is basically 4 motifs. I've got owls in this, but I have prepared shells for a beach-themed one, and there are cats. You know, there are many different designs you can do. This motif here is 3 layers deep, and it's I've made it so that it's like a self-clasp. This is cut flat in one piece, and this is just a ring that goes over these couple layers here of the owl, and that just stays shut because there's actually a little bit of spring on this based on the hinges. The hinges that are between each of the motifs, when you cut them flat, when you draw them and you cut them flat, the width of this space here is 5/8 of an inch. Now, 0.625. And that really sticks with me as a number because the models that I made in my last couple videos of the beach houses, The corner pillars of those houses are all exactly that size, 5/8 of an inch square. So what this taught me, because I'm always trying to learn something from everything I make, is that I can turn a full 90 degrees with this hinge design right here in 5/8 of an inch piece of wood. That is amazingly flexible. That opens up a whole world of applications for that particular hinge design. And the fact that I can lay something like this bracelet out and then just know, okay, I've got a space here, 1.5 inches by 0.625 inch space that I need a living hinge in. Let me draw one and copy and paste it into the other spaces in the design. That's all it takes to do something like this. I will do a separate video on this because in addition to how to design the bracelet and how to do other motifs, I learned some really good tips about working with UV resin that requires, this bracelet here had no finishing other than just being sprayed with sealer. No sanding was done to get the resin in this good a shape. So I'm going to talk to you about how I did all that in my next video. If you like this video, please give it a thumbs up. If you're not subscribed, please subscribe to the channel and turn on notifications so you know when I post a new video.